Welcome everybody to our webinar today. We're going to talk about microservices orchestration with Galileo, Gelato, and Kong, our API management portal and our API management products. We're going to get started by a quick intro about who I am. I'm the VP of Engineering at Mashape. This is actually a presentation we did at Node Day in Amsterdam just last week. So I'm not going to go through all the slides, but you guys are probably familiar a little bit with Mashape. We're an API company. We build API products. We focus primarily on solving API developer problems. And obviously, you guys are here to talk a little bit, to see a little bit about Kong, Galileo, and Gelato, our API management products. But just as you know, we have the API marketplace. It's been our primary product from a few years ago, and that's where a lot of our experience and all knowledge from building these API products came from. All right. So talk a little bit about microservices. If you guys are not familiar with it, microservices is this new definition that's out there today in terms of how to build and orchestrate small components of APIs. If you're interested, there's some links here that you can look up and learn about more about how the kind of microservices mentality or architecture is. But really, it doesn't matter because at the end of the day, we're familiar with the SOA or software service-oriented architecture, and the APIs in general generally follow this sense. So if you're already familiar with it, that's all good. If not, there's some information you can read up about it there. So generally speaking, when teams come together and talk about microservices, the idea is the team comes in and starts discussing the different kind of components or tools they want to build, and they kind of visualize something like this. A number of different boxes, number of different services, coming together to generate the bigger product or the bigger picture. But then what happens is as they start developing it, as they start building these kind of systems that they imagined, things get a little bit more complex and a little bit more extended. So this is where you start seeing some more tooling come into place. And in this analogy, the microservices are the containers and the tooling are the cranes. So it gets a little bit bigger. It gets a little bit unwieldy after a point. And then you go into production and you start seeing some real issues that you didn't foresee before. And that's okay. This is where things you need to learn and understand as you're building a new architecture that you never built before. Hopefully you catch these issues before you hit production. But in a lot of cases, you might end up with some issues and disasters along the way. An ideal scenario, and this is where you hear a lot of the talks and conferences and people talking about microservices, it's kind of this big, beautiful picture of massive amount of containers and services running and a very organized development team and a very organized DevOps team working with a very solid set of tools to deliver these microservices and APIs. But the reality is it's not easy to get to that point. It's something that you need to learn and adapt and grow, both in terms of team and architecture to get there. Eventually, though, things get a bit more complex. So let's talk about a couple of examples of what a microservices architecture would look like in your organization. So in this case, I'm just using a movie recommendations system. So the team again comes together, thinks of all the different components they want to build and how they interact with each other. And then they realize, there's more interaction behind the scene than they initially kind of envisioned. So it gets a little bit complex in terms of the network topology and how things need to communicate over HTTP or APIs or so on. And then you actually want to build this thing to scale. So now you're talking about load balancers and sharing sessions and sharing information and data points across servers and across services. And of course, as your product grows and as your functionality grows, you need to add more and expand on it. So you need to add more services and scale those as well. And then, of course, every once in a while, a new team member joins, or you learn more things about newer technologies, and you decide to refactor or improve the functionality. Or it could even be something that a business requirement that kind of forces you into a refactor or an upgrade or a new version that you need to end up now maintaining a relationship between the old and the new. And this is where it gets complex, because while these things are still talking to each other and dependent on each other, you're not going to refactor them overnight and update them, or you're not going to release a version for everything overnight. So you have to do it incrementally, which means the systems still need to be dependent on each other and communicating between each other. And of course, as with everybody, they should have a level of security and level of identification of the consumer or the entity making API calls. So this is where you start adding more security around them. And of course, as you're talking to any development team or any DevOps teams, there's more information, more functionality that you need to add. The most simplistic of which is logging. And then if you have this kind of big architecture of microservices distributed across hundreds of servers, or even if it's 10, 20 servers, you still have to have a way of logging all the transactions and information across all these servers. And this is where your developers start going crazy. thankfully, there's a solution. The kind of principle here, that the dry principle that we all apply in our day-to-day programming, should also apply to our architecture as well. We don't want to repeat ourselves. There's some functionality and systems that are already there to help us do this. And in our case, when we're talking about API, this is where Kong comes into play. So Kong, simply speaking, is an API management layer. What that means is it reverse proxies all your API calls over HTTP to the upstream server from clients and from other servers. The way it works, it's built on top of Nginx. It uses OpenResty and Lua as the Nginx as the actual HTTP server, OpenResty and Lua as the application framework and programming language. The reason why Lua is chosen is because obviously Lua is a very efficient, very lightweight language. And obviously Nginx is a very well-proven system for HTTP and API call management. The differential part about Kong, as opposed to just using Nginx and OpenResty as they are and building your own functionality, is of course, it comes with a handful of functionality and plugins that are exist out of the box. But of course, more importantly, it makes it very simple and easy to configure a system and launch a system through a RESTful API. And we're going to go into an actual demo in a second and actually show you how everything works. So this is a quick example of you literally just make this API call to the Kong server and create a reverse proxy mechanism with this one curl call, and then create another one with this other curl call. Whereas with Nginx or any other HTTP server, you have to worry about creating a configuration file and then uploading that configuration file to multiple servers, reloading the server, and so on. It can get very complex. The Kong plugin architecture is what allows you to add functionality out of the box that is very simple and very common functionality that you would use across the board. Like we were saying earlier about logging, authentication, and so on. All these things are bundled with Kong. So for example, you can enable rate limiting with a simple API call, and it automatically enables on all the servers in the cluster. You can add logging and SSL. I mean, SSL is one of the more painful ones to set up for any HTTP server. You have to create the certificates and upload them to each server and then configure each server to use them. With Kong, you don't have to do that. You simply make one API call. Even if you have 20, 30, 50 servers of Kong running, you just make this one API call to one of them and it automatically propagates across all of them. And of course, one of the common functionality is authentication, and you can enable that with a simple API call. So the different scenarios that you can use Kong, and we could talk a bit more about it in the demo, as well as your use cases as well. Obviously, the most common one is when you have Kong as kind of the API gateway sitting in front of your infrastructure, as kind of the entry point for any client or application or server or vendor outside of your system that's making API calls inwards. So you use it for protection, you use it for authentication, you use it for logging and auditing. But also internally, as we talked earlier about all these microservices and systems that you're launching, they want to talk to each other as well. So you can also have a level of auditing, a level of control by introducing Kong internally within that. So the microservices don't talk to each other. They talk through the gateway so that you can have a level of discovery, a level of orchestration that happens automatically within the infrastructure. And the same thing if you have vendors or external clients or external systems that you use or services that you use, you can also protect yourself against those vendors. So a couple of different scenarios that illustrate those last 2 points. We actually use Kong in front of our MailChimp application, so that MailChimp is responsible for sending emails and notification emails and so on from our marketplace product. But rather than building logic into our system that kind of worries about counting how many times we've contacted a certain user and making sure that we don't contact them too much, we simply just put Kong in front of the MailChimp API, and our application talks to the MailChimp API through Kong, and we configure a rate limit on it. So the end result was our application can try to call the API as many times as it wants without actually having any context of this user has been contacted too many times or too little times, and then Kong will automatically rate limit per access token so that it doesn't actually go over the limit. So with just simply enabling that functionality, we have protection from ourselves against ourselves by just using Kong within our infrastructure against a vendor application. Likewise, internally, if you have microservices calling each other, say you have a product microservice and a billing microservice, if the product microservice needs to check on the billing status of a system and assume you have a problem or something happens or a bug gets introduced in the product microservice, you don't want to end up DDoSing yourself within your infrastructure. So again, you put up Kong between those microservices so you can have a level of protection from yourself as well. And then, of course, with Galileo, we provide a level of microservices analytics and API analytics that is unparalleled in the industry. So we focus primarily on the HTTP level and everything that happens on the HTTP level in terms of allowing you to create reports and analytics based on anything in the HTTP spec. So you can actually create a time chart view of information based on a certain header query or a certain query string or a certain body element or the combination of all the above. So you can actually filter down and drill through what you would expect in the API to happen, as opposed to just simply a string of logs or a log of strings and a log of data points that may be not relevant to your product team. So this result ends up giving you the ability to have your product team, your marketing team actually use the same analytical tools that your development teams are using. So out of the box, Galileo comes in with a logging mechanism, so you actually keep track of every single API call that went through your system. And then you're able to review it and replay it and actually do a differential views on different API calls, so you can compare how one customer is making a call versus another. And then you can actually allow your DevOps team to also look into the same tool to actually get some insights about the performance, the response times, the speeds, and all the different servers that are running your APIs. And then beyond that, which is something that you never expect from an analytic or logging tool, you can actually give access to your product teams or your marketing teams so that they can actually see how consumers are actually interacting with your APIs and make better decisions and better discussion about the next product goals or the next business goals based on that behavior. We also offer Gelato, which is a developer portal and a developer documentation portal and onboarding for developer. So with the developer portal, you have full access to documenting your API, and it's a dynamic experience, so you can create and customize your APIs. And then you can actually have an API explorer that the developers can use to actually view and test your APIs. More importantly for us, what we try to focus on is the developer experience. So whether those developers are internal to your company, as in other teams or your own team, or it's external developers in case you want to have an API program that's open to the public, it's all the same experience, it's all the same result. The focus is to making sure the developer has the right information in front of them about how to consume APIs and how to build their application based on that API. So the onboarding experience is what we focus on in Gelato. And of course, it comes in with all the documentation and the importing and exporting of different formats and different code generation. That's it for the kind of quick presentation. I'm gonna, at this point, I need to add a slide that says, "Shut up and show me the code." So I'm going to do that. So let me launch the browser here quickly. So if you have any questions or any kind of inquiries about Kong, obviously getkong.org is the place to visit, where all the documentation, all the information is. It's worth noting that we have a number of distributions out of the box, including all different Linux and Debian and CentOS and images that you can use or packages you can use. We also have Docker as well, which I'm going to use today for simplicity because it's super fast and easy to set up. And then, of course, we have Linux AMIs and the marketplace and Linux and the AWS CloudFormation templates that you can use as well. Very soon, we already have a Windows Azure setup that one of our community members have built. We're just adding it to our official installation page soon. And we have a few other kind of deployment mechanism for cloud service providers that we're going to add as well. So like I said, today I'm just going to use the Docker setup. And for the Docker setup, it's very simple. You just need Cassandra and the initial image of Kong, the official image. So I'm going to launch Cassandra. Nope, I don't have it. All right. I'm just going to copy paste this. All right. Oh, good. It's already launched. And I'm going to copy paste this. There we go. So this command, it might sound long and complicated, but it's fairly simple. If you're not familiar with Docker, all I did here is launch a virtual image of Cassandra on my local machine, and I mapped the ports of Cassandra locally. And again, I launched a virtual image of Docker on my virtual machine, linked it to the Cassandra image, and exposed some ports in here. So these ports require some explaining. So obviously we have the 8000 port, which exposes the proxy port on HTTP communication, and then we have 8443, which exposes the proxy port on HTTPS communications. And then we have 8001, which is our admin API port. This is the port that you would interact with to make any configurations in Kong. And then there's the other two ports, 7946 on UDP and TCP that are basically the serve ports that are used for clustering. So those will be important for allowing Kong to cluster itself in the network. So to quickly test if our Kong installation is running, we just make a call to localhost on port 8001. As you can see, I get the response back from Kong. This is all the configurations and all the status information about this Kong node. I'm not running any cluster because it's just a single instance right now. But if I am to run a cluster, I just simply add another node instance, Kong instance, and then it automatically discovers each other as long as it's using the same namespace and the same Cassandra table. So to set up an API in Kong is fairly simple. Like I said, there is the admin API that runs on port 8001, and we just make API calls to it. So if we make a post call to /APIs, give it a name. In this case, I'm going to go with mock, and define the upstream URL. And let me make sure the system, we can just use the web one, mockbin.org. So what the upstream URL is the location that you want to reverse proxy to. So this could be a local address, could be an IP address, could be a DNS name. It could be anything really that you want to use. It's up to you of how you want to set this up. You could actually use a service discovery platform like Console or anything else, as long as it's a DNS name that can be looked up or an IP address that can be looked up. So set up the upstream URL is fairly simple. And then we set the request host. So request host, also two methods of actually doing routing in Kong. You either do it through a request host or request path. There's going to be more features and functionality added later in terms of doing routing by header name or by request method and so on. Those are coming. So in request host means it's a DNS name. So it could be anything. By request path, obviously, it's a path name. So it could be /API, /mock, or anything else you want it to be. Both of these things support wildcards, and in the future, they're going to be supporting regexes as well. For the purpose of this demo, I'm just going to use the request host for simplicity. Great, so I made that post request to Kong on /APIs, and as you can see, Kong responded back with a API entity here. What this API entity is, it represents the routing mechanism that Kong is going to use to determine what to do with incoming calls. So if I add another one here, for example, something else, and instead of mockbin.com, I'm going to go matchshape.com. Again, it doesn't have to be an API. Kong doesn't actually care. It's very unopinionated about what you're doing with your HTTP layer. So you can actually, I should name it something else. You can actually point it to any service over HTTP and it will work fine. So now we have two entities in the system. So if we make a quick get call on the /APIs, you can actually see there are two APIs configured here. Now what this means is if I make a call to Kong, but this time over the proxy port, and I specify a host name that matches any one of those two, so anything.com, this should actually send me to mockbin.org. And indeed it did. So as you can see, this is a response back from Mockbin. Let's do something more meaningful, because Mockbin is actually a service that responds with nice APIs. There we go. So as you can see, this is a response back from Mockbin. And what Mockbin does, in case you're wondering, it's a mocking service. And this endpoint in particular, /request, responds back with an echo of the information that it received. So in this case, these are the information it received from the request that we sent. So if we try again with matchshape.com, this will respond, I think, it's something else.com. There you go. Now it's actually getting the response back from the Matchshape website. So if the host name doesn't match anything, or I'm using a request path that is not, it's 8,000, that is not matching anything in our configuration, obviously Kong will respond back with a 404 saying they couldn't find anything that matches these values. So let's go back to our original call here to Mockbin, because we're going to use this a lot. As you can see, this is, at this point, it's not doing anything unique. It's just doing a reverse proxying setup, which again, you can do with Nginx out of the box quite easily. The difference is with Nginx or with any other HTTP server, you actually have to configure that with a configuration file, upload the configuration file as many times as you have servers, and then restart all these servers. In the case of Kong, you notice I didn't have to upload any configuration file. I didn't have to restart anything. I just simply make an API call to the admin endpoint and configure those systems. And that's really one of the many benefits of Kong. But let's talk about something more than just a simple reverse proxy. Let's talk about something that one of the most common use cases of API management is rate limiting. So in order to enable rate limiting on Kong, and this is where plugins come into play, let's quickly talk about plugins. At this point, I have no plugins enabled. There's nothing on this API. So let's make a quick post to the API called mock on the plugins endpoint for that API and configure a quick plugin. In this case, I'm going to go for the key auth plugin, which is the authentication based on a key in the header. And each plugin, of course, has a number of configurations. So in this case, I want to tell it what key name to look for in the header. Oops. I typed something wrong. Oh, it's APIs. There we go. So as you can see, I created a configuration for the key auth plugin that is associated directly with this API. And this configuration includes this customization of this particular plugin's setup. So in this case, we're looking at configuring the key names to be XAuth. Now, what this means is now this plugin execution, this plugin logic will execute as part of the request lifecycle. So if I go back to my proxy call here that I did earlier to mock bin, it's actually going to fail because now it's actually executing the plugin logic and it's responding back with a 401 unauthorized because there was no header that matched that thing that I'm looking for. Now notice I didn't actually set any credentials yet, so if I do try to set a credential or a random credential, it's going to say forbidden. But of course, this is expected because I haven't configured any consumers in the system. So the consumers are the third topmost entity in Kong. So let's talk about those quickly. And I have nothing configured just yet. So consumers are this abstract notion that we choose to use as opposed to users or applications or any other labeling for what this means, because we really want you to be the one to decide how and what those consumers represent. As a simple example, you can use a consumer to represent actual end users. So each credential for each of the consumers would represent a user's credential. Or you can use them to represent a internal API or server definition, as we talked about earlier. If you're using Kong between your servers or between your applications, each consumer might represent an application, and then therefore the application itself might have additional users within it. So it depends on your way of configuring and setting up the consumer objects and entities in the system that can determine what they actually mean to you. So let's make a quick consumer object entity here. So just make a post request to consumers. We can either use a username or we can give it a custom ID. And in most cases, you really want the custom ID because this custom ID can match to map to something in your system, such as a CRM system or your own database of users. So you can actually do more business logic upstream after the fact. So at this point, I've created two consumers, but I haven't created any credentials for them yet. So let's take this consumer, for example, and give it a credential for the key auth plugin, which is the plugin we just enabled right now. So in this case, I'm going to give it a key, and I'm going to call it ABC123. Great. So I've created a credential that is specific to this consumer for the key auth plugin. So if I go now to my API calls that I made earlier, and this time I actually put in my key, ABC123, it's going to actually allow me through, and it's going to get the response from mockbin. And Kong is going to send mockbin, or the upstream service in this case, the actual consumer identifier and the consumer custom identifier that's in the system so that you can actually execute any custom logic upstream based on that consumer. One interesting thing to note is that if you go back to this consumer, as you can see, the key auth endpoint might have more than one. Oh, I made another post here as opposed to a get, which is fine because it just generated a key for me in case you didn't notice. If I do a get on the key auth endpoint, you can notice that this consumer now has two keys. So each consumer can have as many credentials as you want, and each API can have as many authentication methods as you want. So you can have an API that has both basic auth and key auth and OAuth2 and perhaps JSON Web Tokens all together at the same time, and then you have as many consumers as you want, and then each of these consumers can have any number of keys you want or any number of credentials you want for each of those configuration methods or authentication methods. So the end result is, as I described earlier, if you want to think of the consumer as a user, then naturally they would really only need one credential. But if you want to think of the consumer as an application, then of course you can have as many credentials in that application as there are users. So that way you can distinguish, for example, an Android application versus an iPhone application. And the Android users get generated different keys for their Android app versus their iPhone app, but it's the same consumer at the end of the day. So why is there this difference, and what's the value of having consumer objects? Well, let's talk about plugins again quickly. As you saw earlier, we have this one plugin configured, which is, in this case, the key-off plugin. But let's say we want to do some logging or something more interesting. So let's look at our plugin gallery of the plugins available for us. Like I said, there's a number of authentication methods, including OAuth2, JSON Web Tokens, HMAC, and so on. There's a number of security methods you can enable or plugins you can enable, and there's a number of traffic control plugins you can enable. And there's, of course, third-party systems that you can use, including our own Galileo and Datadog as well. And down there, I think there's Loggly as well for logging. And there's, of course, logging plugins and transformation plugins. All of these things kind of come together to form all the different functionality that you would need from an API gateway. In the case of rate limiting is probably one of the most common ones you'd expect to have in an API management gateway. You can actually configure any plugins other than the authentication plugin. You can configure those across APIs and across consumers and APIs. So what this means, to give a good example, is in the case of rate limiting, I can provide a global rate limit for that API that I just created, and then I can make exceptions per consumer. So let's do a quick setup of this and show you how it works. So again, if I make a post to plugins, I'm going to put an API ID, and I'm going to give it a name. The plugin I want to enable is, in this case, rate limiting. And let's do some configuration here. I'm going to go per minute equals 5. And that should be enough. As you can see, we got a configuration for rate limiting enabled specifically on this API and has a limit of 5 calls per minute. So what this means now, if I go back to my proxy call, and if I call it 1 time, 2 times, 3 times, 4 times, 5 times, and now by the 6th, I'm getting blocked. And of course, responding back with a 429 and a rate limit exceeded message. This is great. Now I have rate limiting on this API. But what if I have a specific consumer or a specific user that's actually being malicious or actually is not following the rules in terms of the API? Or perhaps I want to sell access to this API and want to add rate limiting as a way of limiting users' access. So again, we go back to the exact same call we did earlier. And I'm going to actually steal the consumer ID from here to make it simple. And simply type in consumer ID as one of the parameters for configuring this plugin. Give it a lower rate, let's say 2 per minute. And just to quickly kind of recap, if we look at the /plugins endpoint to see all the plugins enabled with a GET request, you can see I have 3 plugins enabled at this point, which is the authentication plugin that I enabled the first, and then the second, the actual global rate limit that I enabled. But then there's another rate limiting enabled, and this time it's associated with both the API and the consumer. So what this means is, in terms of execution logic in the request lifecycle, the plugin for authentication would run first, of course, and then the rate limiting plugin will have to decide whether it needs to run globally or per consumer configuration based on the authentication of what the authentication plugin has done. So if I've authenticated a certain user and it matches the consumer ID specified here, then of course this particular configuration would run. If not, it will run the other configuration. And you can do this as many times as you want across as many consumers as you want. And obviously I've been talking too long just so I can spend a minute and actually have the rate limit reset by now. So if I go back to this call and do it again, 1 time, 2 times, and then by the 3rd time I'm locked. And as you can see, I have a different rate limit now than what I already started. So this is a quick kind of intro of how to configure and set up Kong across all the different rate limitings and plugins and functionality that you have. This is the power of plugins when it comes with combination with consumers. You can actually have a global configuration for a plugin versus a consumer-specific configuration for a plugin. Next, I'm going to move on to talk a little bit about Galileo and Gelato. So like I said, Galileo is our API analytics platform, and it's focused entirely on API analytics. And for explaining what that means, I'm going to go dive straight in. And hopefully I'm logged into the correct account. If not, I can change that. Yeah, that's fine. So out of the box, when you first join Galileo, you're presented with the question of creating an environment. What an environment is kind of a bucket where all your information is gathered and collected together and grouped together. So you can think of it as, production versus staging, local versus remote. Doesn't really matter. You can think of it as server A versus server P. It's really up to you to define how you want to bucket your information and group it. So in this case, let's call it, oops. Let's make a new one called Feb demo. Great. The next step is to connect the data source. Now, Galileo, like I said, is an independent application. It's an independent product. It is not part of Kong. All of our products, in fact, are standalone and independent. And the reason for that is that we can choose the best tools for solving the problem domain there. So in this case, we're looking at analytics tooling as opposed to API management and gateways there. So you can actually use it directly with Kong, meaning that if you have Kong running as we are today, you can just make an API call to the Kong admin, configure the Galileo plugin on Kong, and automatically can configure the information going through to the Galileo servers. Or you can use it with a very lightweight proxy that doesn't have any functionality at all other than just logging the information and sending it to Galileo. And there's, of course, a number of SDKs and libraries that you can use. So if you have Node.js application, Python, JavaScript, and a few other languages that are coming, you can simply add the middleware to your setup and directly on your API code base and actually have the logging happening on that end. And you can use all of them together. So I'm going to use the test environment for now just to populate some data and show you guys a quick demo. So out of the box, it comes in with a log view that you can actually inspect and view all the information in your logs. So you can actually see exactly what's being sent over the request and the responses. You can even compare different API calls, so you can actually see any differences between them. In this case, it's completely different API calls, so it's getting different results. You can compare the requests and the responses, so you can have a quick view into determining if a client is making something wrong in a call or not accurately making a body request or the request body. In terms of the information presented here, this is all customizable, so you can actually go in and choose what fields to display, and those fields are actually based on anything in the HTTP spec. So you can actually choose a dimension of anything in the HTTP spec to display in the request. So let's say you want to do, I don't know, choose something random, let's say. Let's say we have an accept header. Let's display that. Save that, save the table, and then the accept header will be added. In this case, this is a dummy data set, so it doesn't actually have an accept header, which is not good, but just a dummy data set. And you can actually sort this table any which way you want. So this will be just like your log view table, and of course allows you to quickly filter. So you can click on any dimension and actually quickly filter it to get some more details about the results. So in case you want to see only 200, you can see the filtering happening here. Or you can provide any of your, again, anything in the HTTP spec in terms of filtering, you can do that. So you can say path contains a certain word, let's say customer. You can add that as a filter. Oops. There you go. Now it's just going to filter based on anything that has this host header, this response status, and contains this particular keyword. Going back to reports. Reports is where the information comes together and gets aggregated into meaningful data. So out of the box, you get a number of reports that represent your different views into your API. So you can look at the errors, you can look at payload sizes, request by URL, or anything else you want. You can create your own report. So let's do that quickly. I'm just going to keep the name. Again, you can have any filtering functionality you want. So you can have, let's say, path contain this. And then you can choose the groupings method that you want to do the aggregations on. So the aggregations is where the value comes into real fruition, where you can actually look at number of calls, latency numbers. You can look at response sizes, and so on. So you can actually create any custom grouping you want, and based on that custom grouping, you'll get the aggregated results. So in this case, let's do, I want to see request method and just response status. And we're actually filtering just on this path. So the system is going to go ahead and create our report for us. And as that's being created, you can actually see the different time frames you can go back to. In this case, we're just looking at the past 24 hours because this is a simple data set. And you can actually change the chart view to a number of different things depending on the type of aggregations that you created. So as you can see here, the grouping is done by status and method. So you can see there has been 424 calls that ended up being with a GET request and a 200 response versus 51 that were with a GET request and a 400 response. And you can actually visualize those nicely. You can on the chart, so you can get a little better view of exactly what the differences are, so you can tell where the errors might be happening. And of course, this becomes more meaningful when you look at latency numbers and response sizes, so you can actually tell if there was issues in terms of how our API is performing or how our API is expected to perform. This is all actually being updated in real time, so once you create a report, it's automatically updated going forward. There's no need to recreate it every time or refresh it every time. So again, you can create filters based on any dimension in the HTTP spec. You can create as many reports as you want, representing all different data points that you want to inspect and view. And this is where the different reports can be serving different purposes. You can have your development team looking at reports for inspecting response sizes or errors or things that are happening in the API that are unexpected. You can have your DevOps team that can create their own reports in terms of latency and performance. And then you can have your marketing teams and your product teams creating their own reports that tells them a little bit about how people are consuming the APIs and what endpoints and what data is being used that might be more meaningful to the business. So like I said, Gelato is our developer onboarding and API documentation product. It's a very simple product in nature, but it's very important in the API program and the kind of life cycle of what your API program should provide for whether it's internal developers or external developers. You want to have a great experience so that developers are able to build and consume APIs. Starting with documentation, obviously, is the starter. You actually have an interactive documentation editor for your API, so you can actually create endpoints, describe API methods and different interaction points with your API, get code automatically generated for that endpoint that you've described based on the input fields. So for example, you can add a parameter. You can put it in the query string or the header or the request body. Let's say it's a Boolean, true, save it. And then you can start seeing those information show up in the actual API generation. So you can actually choose what language you want to use, or you can actually create your custom stuff if you have an SDK or something else, or you can remove the API code generation altogether. Regardless, this form is very flexible in terms of helping you describe your APIs and doing it all manually from scratch. Most people actually use, let's actually go back to the dashboard quickly. Oh. You can actually have the documentation reference in terms of creating a markdown information of describing what your API does and describing things like how to do authentication, how to do error management, and so on. And you can, of course, import API documentation from different providers. So in this case, go back. You can actually import from Swagger, API Blueprint, and RAML into your API portal. And once you do that, you can actually set it up as a GitHub repo or a one-time import. So if you do it as a one-time import, obviously it's a one-time import. If you do it as a GitHub repo, then of course it's going to be automatically synced going forward. Guides is another section that is very interesting. So in terms of having a guided experience of how to build an application and describing something beyond what the API documentation or the API guide might provide, this would be a great place for you to have a more kind of in-depth article-based system that you can actually describe, end-to-end experiences, building experiences using your API. And you can actually segment those per language or tag them per application, so you can, or categorize them, so that you can actually have a more guided experience for your developers as opposed to just plain documentation for them to read. And of course, this is all the admin portal. Once you go to the actual experience, as a developer coming into the system, they're allowed to register and log in using any sort of the social networks or GitHub accounts that you might want to enable or disable. And then they're able to access the reference documents or view the API Explorer. And by viewing the API Explorer, they can simply make API calls to the endpoints that you described and go from there. And I think check true, and then you can send the request. Obviously, I didn't specify an upstream for this, so it's not going to go anywhere. But it's actually going to make the actual API call. And if this API has an API credentials, then the developer is asked to enter that credential. If you are using this with Kong, then this step is automated, so developers can automatically get their API credentials generated for them using Kong, and it actually just displays the results in here. So thank you all for attending, and please make sure you follow up with us after the call if you're interested in any more technical deep dives or technical questions that were not answered, or if you have more questions about pricing and licensing and setup. Afterwards, we'll also do we'll follow up to you with more details about our pricing, more details about our information of what our products being offered, and we'll do that hopefully in the next couple of days. If not, you can just reach out to us directly through sales@mashape.com. Thank you all very much.